Good morning, students. Today we are going to discuss the next topic of your first chapter, real numbers, and that is fundamental theorem of arithmetic. But before that, we should discuss about prime numbers and composite numbers. So what are the prime numbers? The numbers which are divisible by itself and one only are called prime numbers. For example, 2, 3, 5, 7, 11 and etc. These are numbers which are divisible by itself and one only, that is they have only two factors, that is 1 and itself. Such numbers are called prime numbers. And all other numbers which are not prime, they are called composite numbers. A number which is divisible by numbers other than 1 and itself also are called composite numbers. For example, 6, 9, 12, 14, 15 and so on. Such numbers are called composite numbers. It means that these numbers have more factors than more than two factors. For example, number 6. What are its factors? One factor is obviously 1, second factor is number itself, and apart from these two, it has two more factors, that is 2 and 3. Means number 6 comes in table of 1, it comes in table of 6, in table of 2 and in table of 3. It comes in different tables, so it has all these factors. So such numbers are called composite numbers. Further, we all know that we can factorize composite numbers. For example, let us take number 6. If we want to factorize this number, how we will do it? This is number 6. 2 3s are 6 and 3 1s are 3. So what are its factors? Its factors are 2 and 3. These are its prime factors. And factorization in which we reduce a number into its prime factor is called prime factorization, about which you have already studied in previous classes. Prime factorization. Let us take one more example. For example, we have a number 15. If we have to factorize it in its prime factors, how we will do it? We will take first prime factor, that is 3. 3 into 5 and 5 into 1. 5 ones are 5. So what are its prime factors? Its prime factors are 3 and 5. Let us take one more example. For example, 45. We can also factorize it into its prime factors. So let us start from 5. 5 9s are 45. Then 3 3s are 9 and 3 1s are 3. So what are its prime factors? Its prime factors are 3 into 3 into 5. So in this way, you can factorize any composite number. And our fundamental theorem of arithmetic is based on this concept only. Fundamental theorem of arithmetic. What does it say? It says every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. What does it mean? It means that we can factorize all composite numbers. As I have done earlier, if we take any composite number, for example, let us take number 4. If we want to factorize it, we can factorize it as 2 2s are 4, 2 1s are 2. So what are its prime factors? 2 into 2. So every composite number can be expressed or factorized as a product of primes. What is this? We can write 4 as a product of prime numbers. Let us take one more example. Let us repeat the previous example and factorize 45 into its prime factors. So 5 9s are 45, 3 3s are 9 and 3 1s are 3. So what are its prime factors? 3 into 3 into 5. So you can see that we can express 45 as a product of prime numbers. And second thing that is written here is that this factorization is unique. This factorization will be unique. If you will factorize 45 you will get factors 3, 3 and 5 only. You will not get some other factors. Let us try to factorize 45 in another way. Like this is 45. Let us start with 3 first of all. So 3 ones are 3, carry 5, 3 5s are 15. Again with 3 5s are 15 and 5 ones are 5. So what factors we are getting? 3, 3 and 5. So you will see that if we factorize any prime number, we can write it as a product of primes, and this factorization will be unique apart from the order in which the prime factors occur. Means order can change. We can write this as 5 into 3 into 3 also. Order doesn't matter, but factors will remain the same. This is. I have taken one more example. Let us take 42. Now you see here, I have factorized 42 with starting with different prime numbers. For example, first of all I started factorizing it with 2. So I get prime factors as 2, 3 and 7. Then I tried to factorize it with number 3, prime number 3. Then I am getting factors as 3, 2 and 7. And again I tried to factorize it with prime number 7. Then I am getting factors as 7, 2 and 3. So you can check here. In all the cases I am getting only these 3 factors, 2, 3 and 7. It doesn't matter what is the order of these prime numbers, but I am getting only these 3 prime, product of these 3 primes as the prime factorization of 42. So it means that this factorization is unique if we left the order. If we don't consider the order, this factorization will remain unique for this prime, for this composite number 42.